Hi and welcome to the fifth lecture video on Mohr circle. So previously we have already discussed about how to draw Mohr circle, how to plot planes, the Coulomb-Griffith fracture envelope and other fracture criteria, how to use stress tensor, its usefulness and the 3D stress tensor and its solution. So in this video we will discuss about how to plot a Mohr circle from any two random planes and to determine the value of principal stresses. So with that being said, we'll start our video. So let's assume that there are two planes and we have the value of normal and the shear stress on the two planes. So for example, for for plane 1 for plane 1 we have sigma n is equal to 20 and you can consider the unit as a kilowatt, and tau, that is the shear stress, is equal to 5 kilowatt. And for plane number 2, sigma n is equal to 15 kilowatt and tau is equal to let's say 8 kilowatt. So our first aim is to draw the Mohr circle out of these two planes. Okay, let's say here we have plane 1 and here we have plane 2, and this is the center and this one is the radius and this one is the radius. So first we need to draw the Mohr circle. So in order to draw a circle we need actually two things. First one is the coordinate of the center, yes, and second one is the length of the radius, and in this case we have none of these above. So first we need to calculate these parameters. So okay, so in a circle, like in this case, if x is the center and ax is the radius with the coordinate of x is equal to x1 y1 and a is x2 y2. So the length of the radius is equal to x1 minus x2 whole square plus y1 minus y2 whole square and its square root, or r square is equal to x1 minus x2 whole square plus y1 minus y2 whole square. So using this principle, we'll calculate the coordinate of the center and also the radius of the circle, and hence we'll be able to draw the Mohr circle. Okay. So as we have already discussed that both plane number 1 and plane number 2 lie on the same circle, so the radius will also same. So using the formula, it is 20 minus x its whole square plus actually let's assume that the center of the Mohr circle, that is the center of the Mohr circle is x and y, and we have 1.20 and 5, and the second one is 15 and 8. 20 minus x is whole square and whole square of 5 minus y whole square. So this one is r square is equal to 15 minus x whole square plus 8 minus y whole square, and this is also r square because radius is always same for a circle. So if we'll expand it, we'll get 400 minus 40x plus x square plus 25 minus 10y plus y square is equal to 225 minus 30x plus x square plus 64 minus 16y plus y square. So y square cancel, x square and x square cancel. So this implies now we have minus 40x minus 10y, and if we'll take it to this side, so it will be plus 30x, so this will be minus 10x. Then we have minus 10 y here and minus 16 y here. So if we will take to this side, so it will be plus 16 y, and the overall value is plus 6y and plus 425, that is 425, and 225 plus 64, that is 289. Okay, so minus 289 is equal to 0. This implies minus 10x plus 6y plus 425 minus 289 is equal to, okay, 136 is equal to 0. If we will take common, if we will take the common negative, so 10x minus 6y minus 136 is equal to 0, or else we can write it as 10x minus 6y is equal to 136. It is equal to 10x minus 6y is equal to 136. So this is the equation that we got by equalizing both the previous equations. So we need to find what is the x-intercept and the y-intercept, and actually we don't have anything to do with the y-intercept, because in Mohr circle we know that the center always lies on the x-axis. That means the coordinate of the center must be in the form of like x1 and 0 or x0, because y is always 0 for the center of the Mohr circle. So from this equation we need to find what is the x-intercept. It is the x-intercept. So the x-intercept will get by putting y is equal to 0. So putting y is equal to 0, we will get 10x is equal to 136 and x is equal to 13.6. So now we got the x is equal to 13.6, and previously we have already discussed that we have assumed the center of the Mohr circle as x and y. Here y is equal to 0 and x is equal to 13.6. So we got the coordinate of the center, that is 13.6 and 0. Now we have to calculate, this is the coordinate of the center. Okay, and now we need to calculate the length of the radius. Okay. Length of the radius. So the length of the radius will be simply 20 minus 13.6 and its whole square, because in this circle, let's assume we have here 20 and 5, and the center is 13.6 and 0. 13.6 and 0. So the length of the radius will be 20 minus 13.6 plus 5 minus 0 is equal to 5, its whole square and its square root. Okay. So okay, so this one will be 6.4 whole square plus 5 square and its square root, and 6.4 whole square is equal to 40.96 plus 25 square root, that is 65.96 square root, that is equal to 8.12. Yes, so the radius is equal to 8.12. Now okay, so we have the for the Mohr circle we have the center as 13.6 and 0, and the length of the radius is equal to 8.12. So can we calculate the two principal stresses, that is sigma 1 and sigma 3? Yes, very simple, because by adding the length of the radius to the center, we'll get the value of sigma 1, and by subtracting the same from the center we'll get the value of sigma 3. That is, from 13.6, if we'll go towards our right of 8.12 unit, then we'll reach at the point of 8.12 to 7, and this is 21.72. So this point is 21.72 kilobar, and similarly 13.6 minus 8.12, that is 8 4 and sorry, and this is 5.48 kilowatt. So for the point 20 and 5 and 15 and 8, we'll get the sigma 1 as 21.72 kilowatt and sigma 3 as 5.48 kilowatt. So now we can draw the Mohr circle, that is 13.6, here it is 21.72, and here it is 5.48. We have the tau axis here, and the sigma n axis somewhere here, and if we'll plot the 2 points, then one will be somewhere here or one will be somewhere here. Then also we can also calculate the angle between the particular plane and the sigma 1, because if we'll calculate this value, then we have to just make it half to in order to get the value that this plane is making with the plane sigma 1. Will also the same is also applies for the for this plane, if this is plane number 1 and this is plane number 2. So if we'll calculate this angle and we'll just make it half, then also we can calculate the angle between this plane number 2 and sigma 1. So we'll just check our answers from the program or from the software. That is, we are getting sigma 1 at 21.72 and sigma 3 is 5.48. So from the program, okay, calculate principal stresses from planes. Okay, then we'll put the sigma n value as 20 and tau value as 5, and for the second plane it's 15 and it's 8. Now you can see, just make it. Now you can see that the sigma 1 magnitude is 21.72158 and the sigma 3 magnitude is 5.47842 per, which is almost 5.48. So if we click OK, so now this is our Mohr circle, and this is okay, this is plane number, it is 20 and 5, that this is plane number 1 and this is plane number 2. So okay, so if we draw the construction line, so this angle is the that is 2 theta for plane number 1, and this angle is the 2 theta for plane number 2, and okay, so plane number 1 actually makes an angle of 18.99937. That means okay, if you consider it as 19, so it's almost 38 degree. This is almost 38 degrees. So if we'll go from center to this one, you can see at the left side bottom of the program, that is the value showing approximately 37.89873 or almost 38 degree. And for plane number 2, if we do the same, then we are getting 80.09998, and by dividing it by 2 we'll get the value of the angle, that is 40.03, obviously. And these things we have already discussed in the lecture video number 1 and 2. So this is all about Mohr circle that you need to learn there are many aspects of Mohr circle that we have discussed in this lecture series. And for the next series, actually, I am planning to make a long video series of structural map and how to interpret map, some deep strike problem. So if you are interested in those things, then you can let me know in the comment section, and I'll try to make better videos, and I'll try to upload the videos as quick as possible. So I really thank you for or to all of you that you listen me patiently, and thank you for your support and your love. Thank you.